3, 2, 1.
Here we go!
Good morning, everybody, and welcome to another edition of Case Live. Thank you for joining us on this wonderful February morning here in Racine, Wisconsin. And we're glad that you took time out of your day to join us. I am here with none other than Mr. Jeremy Dulock, and making his Case Live debut, Mr. John Wint. We'll take it easy on you. It's first time.
Appreciate that.
It'll go well. We got a lot of good things that we're going to go through here today, but to go over the initial housekeeping first, as always, at the bottom of your screen there is a Q&A box. That Q&A box, this is not a situation where you've got to hold questions to the end. Drop your questions in that Q&A box throughout the day today, and then as we get through the initial discussion point here, we'll throw questions at these folks and have that good conversation. So what are we here to talk about today? We're here to talk about undercarriage, and why are we here to talk about undercarriage? There's a lot of things that go into the discussion, but the thing that we often lead with, and it varies from machine to machine, is that such a big part of that initial purchase price of a machine is tied into that undercarriage. And then depending on the type of machine you have, whether it's an excavator, whether it's a CTL, whether it's a dozer, anywhere between 40 to 60% of the lifetime owning and operating costs of that machine are tied just into that undercarriage. So what we talk about a lot in talking about total cost of ownership are the daily basic things that you can do in order to help keep those costs down, and that's what we're going to talk about with Jeremy and John here today. So the first thing, we're going to carve this discussion up into a couple of pieces. The first thing we're going to carve it into are the things that we can control. Whether you're a fleet manager, a business owner, or the equipment operator, there's many things that you can do that will affect the lifetime owning and operating costs of that undercarriage on your machine. And Jeremy, the first thing that we're going to talk about is decisions that you can make at the time of purchase. And your area of expertise is dozers, but it really applies across all machines. What are some of the things we should be thinking about at the time of purchase on a machine like this that will affect the lifetime owning and operating costs related to undercarriage?
Thanks, Bill, and thanks for everyone joining us today. You're absolutely right about what I'm about to say will vary machine to machine, but all important things to keep in mind. On machines where you have a choice between rubber tracks or steel tracks, those rubber tracks will wear out faster and require replacement. But they'll also allow you to move that machine across asphalt, concrete, and other finished surfaces. So knowing how that fits into your operation is important. As we look at steel tracks, there's a general rule of thumb. The narrowest track gauge with the narrowest shoe width for proper flotation and tractive effort will result in optimal undercarriage life. On dozers, matching a track style to the work you do will go a long way to ensuring productivity and proper machine operation. For firm ground conditions with minimal slope, long tracks are the best fit. With narrow track gauge and narrow track shoes, they provide high ground pressure and the best traction. When it comes to firm ground conditions with more varied terrain, wide tracks are the preferred track option. Their wide track gauge and wider track shoes provide lateral stability in sloped areas. Low ground pressure tracks are the best suited for soft, swampy ground conditions. The wide track gauge and the widest possible track shoes ensure lateral stability and the best flotation. On excavators, we don't have the same formal naming convention as dozers, but width, length, and grouser height matched to your most common ground conditions will drive success. There's also a general consideration to think of as you're buying a new machine, and that's the machine's size and weight. We know some people operate by the bigger is better mantra, but if your application doesn't need the largest machine available and you can complete your work with a smaller, more mid-sized machine, that will obviously have a lower initial purchase price. But there's something not everyone thinks of: weight. The heavier the machine, the more stress and strain being put on those tracks, which will lead to higher lifetime maintenance and repair costs. For many, it's the price of doing business, but given these considerations at the time of purchase can help keep some of those maintenance costs in check over the life of the machine.
Yeah, it's absolutely, it's maintenance costs, and then also you think of transportation costs. If you don't have to have as big of a machine, it's much easier to transport from job site to job site. John, we talked a little bit about, Jeremy covered off very well on some of the initial considerations, whether it's at purchase or machine selection phase. Operators play a big role in the lifetime health and performance of undercarriage. Give the folks at home a little bit of an idea of some of the things that operators can do to help better extend the life of the critical components that these machines ride on.
Sure, absolutely, I'd be happy to. Operator habits on all types of undercarriages do play a big part in how fast you experience wear and maintenance. Let's look at a few of the things that operators can do to improve the undercarriage life. First is operating rubber tracks on improved surfaces. Concrete, asphalt, and hard-packed gravel all tear up rubber tracks when consistently used on these surfaces. The vibration, the abrasion, it's all going to wear on those rubber tracks. Now, obviously, we're not recommending that you operate steel tracks on concrete and asphalt, but this is more of a note related to avoiding extensive use of rubber tracks on these hard surfaces. Avoid it if at all possible. Next is counter rotation. Every operator does it, and there may be a specific reason in some applications. And it can be the quickest way to turn around a machine, but the counter rotation of a machine in one spot puts all sorts of unnecessary stress and strain on that undercarriage. Where possible, we highly recommend wider turns or even Y turns to prevent excessive wear. Next, always turning in one direction is not advised. While we do have a new partnership with World of Outlaws Racing, where left-hand turns are the normal, we recommend operators alternate turning direction on track machines if at all possible. Constant turning on one side will lead to asymmetrical wear. There's things you want to keep in mind as it relates to operating on hills and slopes also. When you have to work on a slope, we recommend you work directly up and down that slope and minimize any sideways work on that slope. Operating sideways on a slope places greater pressure and wear on the side of the track that's downhill. Operating in this way consistently, always with the same side downhill, will accelerate the wear on that one side in comparison to the other side. Other common behaviors that increase wear are consistently fast speeds and consistent operation in reverse. Both types of operation increase wear rates on pins, bushings, and sprockets. Operation in reverse wears an undercarriage nearly twice as fast as operation in forward gears, as while in reverse, you have roughly 50% less pin to sprocket contact. And remember, if you eliminate driving in reverse to start your next pass, make sure you're making equal left and right turns and not counter-rotating to start your next pass. As much as anything else, wear is a function of speed and distance traveled. Operating deliberately and with fewer long runs or pushes will help extend undercarriage life. And you'll want to avoid track spinning. This is particularly applicable to dozers and CTLs, but don't operate in a way where you put too much of a load on the front of that machine to the point where you can't push effectively and the tracks just spin in place. Adjust bucket and blade load accordingly. It will actually increase your productivity as well, versus sitting and engaging in unproductive work.
Thanks, John. And those operators take a lot of pride in how they operate, but even minor coaching tips on proper operation like that can go a long way into minimizing that wear and helping extending the life of the undercarriage. We've got two guys that you've been very familiar with seeing on Case Live over the course of the last year or so. They couldn't be here with us today for a variety of reasons, but both of them had a thought or two they wanted to share with you. The first one we're going to throw it out to Nathaniel Waldschmidt. Are you there, sir?
Thanks, guys. In general, when you get to a job site, make a plan. Set up the flow of the job site in a way that minimizes machine movement as much as possible. Ask yourself, how can I complete the job in as few passes as possible, or with minimal machine movement? How can I avoid obstacles? Taking that time will help you better run a job site and help minimize wear on your equipment. And as it relates to excavators, Plan and set up your job site in a way that allows for optimal digging conditions. You never want to dig over the sprocket. I think some people don't realize that there's actually a proper front and back to excavator tracks. And similarly, don't set up digging operations in a way that you have digging over the side of the machine. That will put unnecessary stress and strain on that side of the excavator. And with that, I'll throw it back to the fine folks in Racine.
That's a great thing to share, Nathaniel. It's not uncommon to pull up to a job site and to see an operator digging off the wrong end of the excavator, and so that's a good tip to share with people. Similarly, Richie, you took a moment to chime in here. I think you've got a point you wanted to share that we missed.
Guys, Case Live, I love it. You guys are rocking it, but there's something you forgot to talk about. There's another great way to reduce the amount of wear and tear that goes on in these dozer undercarriages. That's right, with machine control. Machine control lets you complete grading in fewer passes, which means you complete the job faster and with fewer hours on the tracks. That's really going to add up over time and ultimately allow you to be more profitable with less wear and costs going into those tracks. And telematics. Case SiteWatch comes standard on all new Case heavy equipment as a part of ProCare. And that's going to help you keep better track of hours and better benchmark service as it relates to lifetime undercarriage needs. Boom. Have fun, guys.
Thanks, Richie, and thank you, Nathaniel. I miss you, goofy fellas. We'll have you back on Case Live here before you know it. He brings up a good point, though. He brought up telematics and maintenance. Let's talk now, Jeremy, about some of the maintenance-related items that we want to make sure we're doing regularly for the upkeep and health of the undercarriage.
Yeah, thanks, Bill. The operational stuff that John talked about is absolutely critical. But then there are the things we do in the day-to-day maintenance and upkeep of the undercarriage that also can help extend its life and performance. The pre- and post-operation checklist is a good place to start. Brad and Ted did a whole Case Live on this topic a while back, but it's worth revisiting. Even a visual inspection at the beginning and end of each shift can go a long way in identifying wear patterns, damage, or areas that may be vulnerable to wear or failure. Making that visual inspection consistent will help you identify anything out of the ordinary as it comes up. We provide a visual inspection chart with every dozer as a reference that operators and mechanics can use to compare the machine to. Another often overlooked task is cleaning the tracks at the end of the shift. It's a good thing to do for a few reasons. Impacted dirt and rock acts as an abrasive as the undercarriage works. So removing as much of that as you can at the end of the day helps support less wear. A clean undercarriage will help you spot wear easier, as well as signs of premature failures or catch problems when they are small before a major failure, like oil leaking from a failed seal on a pin or bushing. And in the winter months, materials can freeze, particularly harmful for smaller rubber-tracked machines. Another thing to confirm during a regular inspection and during service is that the tracks are properly aligned. Correct track alignment is necessary to prevent wear of the undercarriage components. Misalignment problems will affect more undercarriage components than any other issue. Track links, idler flanges, track and carrier roller flanges, sprockets, and rock guards can all suffer from increased wear when the tracks are not properly aligned. One thing that can be checked daily is track tension. When steel tracks are too tight, it creates added load on contact areas, which accelerates component wear. A track that is too tight also robs the machine of its power and fuel efficiency, as it actually takes more effort to turn the track. If a track is too loose, it can create instability and potentially cause the tracks to derail, while also causing wear on other components of the undercarriage. Track tension should be checked daily, with the sag adjusted to the recommended measurement for each machine. If conditions change throughout the day, check track tension as the machine settles into that new working environment. When working in mud, snow, and sandy conditions, the track tension should be checked more often. Material will pack on the undercarriage parts and increase the track tension.
Thanks, Jeremy. That's a great point. All those environmental factors really add up to impact the performance and health of that undercarriage. John, I want to talk with you a little bit. We've talked in the past about undercarriage measurement, and I think that's a thing that not everyone knows how often to do it, where to go to do it, and let's run through a little bit of that, John. Tell us about undercarriage measurement and what people learn from that and how it helps extend the life of that critical undercarriage.
Absolutely. Undercarriage measurement sounds like a daunting task, but it's not, and the payoffs are huge. As mentioned, another service-related activity that should be done regularly is an official undercarriage measurement. Most people will partner with their dealer on this, but an experienced fleet manager or mechanic can do this as well. This activity measures things like track pitch, external bushing diameter, link wear, track roller tread wear, and grouser height. One of the main reasons you should do this is that it may help you catch small problems that can be easily corrected or fixed before they become major downtime events with the related repair and replacement costs. You're also going to learn things in that process. For instance, your dealer service tech may notice wear patterns within the undercarriage indicative of operating practices detrimental to the health of your undercarriage. You can use these findings to coach operators to show them how to manage long-term owning and operating costs. You'll also be able to plan better for the maintenance and eventual replacement of that undercarriage. Taking those measurements and keeping track of the pace of wear will help you understand how much time your undercarriage has left and helps you plan for that replacement cost when the time comes. It will help you stay ahead of specific part and component replacement and help your dealer ensure that they always have the parts and components you need before it ever becomes an issue. And, as always, read the manual and keep up with any maintenance schedules and charts provided by the manufacturer. Every application, every soil type, every operator is different, so that's not a guaranteed schedule. You need to put in the work and monitor performance and wear and service, but the manufacturer provided guidelines and schedules point you in the right direction.
Yeah, thanks, John. I think that's something that's often overlooked. Just a little bit of attention, a little bit more of intentional focus on those schedules and on the measurement and the performance of those components will go a long way in extending life. We're about to transition to the Q&A session. Put your questions down in the Q&A box below. But before we do that, a little treat here in Case Live. You might be familiar with our Tech Talk series. That's a short series of videos with little helpful hints and tricks on how to improve equipment performance. One of the first ones that we did some years back is with a much younger Brad Stemper, and we're going to play that on CTL track upkeep and maintenance. It's an older video, but the truth of it remains the same. We're going to play that. We're going to see what Brad looked like a few years back, and then we'll take your questions when we come back. Thank you again.
Hello, my name is Brad Stemper, Solutions Marketing Manager for Case Construction, and today I'm just going to take you through a real quick understanding of rubber tracks on compact track loaders, what is the best operation practices, as well as where are the best applications to operate them in. With a compact track loader, you really want to understand where you're operating that machine. You want to work on unimproved surfaces. If you're working on concrete, blacktop, rocks, you will definitely have more likelihood of damaging or wearing those tracks prematurely. You want to take this machine due to its traction and flotation to unimproved surfaces. Places where it's going to be sloppier early in the year or late in the year. Places where you want to have less ground disturbance, as well as situations where you need that additional traction driving into whatever kind of work you're doing with the attachment. So the first thing to understand about your rubber track undercarriage is that this rubber is going to be softer than your skid steer tire rubber. It's going to wear a little bit more quickly. So you really have to plan your job site. That's tip number one, is planning the job site. Understand where you're going to be operating, understand where you can make productive turns, and understand where you can avoid obstacles. One of the things that you don't want to do is make counter-rotating turns on these. Counter-rotating really wears your tracks quickly. So you want to make wide turns, you want to make curving turns. Another tip about operating your undercarriage is knowing and tracking wear on the rubber track itself. Most tracks on CTLs are non-direction specific tracks, meaning you can take this track and put it on the opposite side of the machine and take that one and put it on this side, or you can reverse the direction of this track. So what was forward direction in the past is now rearward direction. You're simply using more of your track when you rotate your tracks. One of the biggest things that operators really need to understand is, like any other track machine, it's track maintenance. And there's not a lot you need to do on track maintenance other than cleaning the undercarriage. Primarily, you're going to want to clean the undercarriage at the end of each operation. And the main benefits of that is reduced friction, reduced wear, as well as if you're operating this machine in cold weather, less likelihood of binding the tracks because everything becomes frozen during its downtime. Spend a few minutes, pull away any dirt and material that you have on the tracks, and then shut it down for the day with confidence that tomorrow you'll be able to start it back up.
You know, I think when we thought about putting that video in there, we thought maybe Brad looked even younger than he did, but Brad's still looking good even all these years later. So we're here, we're at the live Q&A part of the morning, and before we do that, I'm gonna drop a few links here into the chat box. We've got a lot of great questions coming in, really good action in the chat, and a couple of things we're gonna address here quickly. But first, I am going to drop here into the chat box 3 links. The first is, as always, we're excited to announce the next episode of Case Live. At the end of March, this is one we've been looking forward to for quite a while. We are going to talk about all of the awesome options and features and things you can do to enhance your backhoe. So think of any other options or things that you can add to enhance its performance. We're going to dedicate an entire Case Live to that. And we know people love their backhoes, and we look forward to you joining us on that one. I also dropped in links to 2 additional video resources that you will be able to bookmark and watch at your own leisure afterwards. It digs into a little bit of what we've already talked about with these gentlemen, but good resources to keep on hand. I'd like to welcome, one of our favorite things about Case Live has been we've seen great engagement from technical schools, and we saw in the chat box that our friends from Moraine Park Tech College are watching us here today. I hope you all are doing well. A couple other quick shout outs. We just spent time last week with the folks at Leica down at their winter convention in San Antonio. I see Tony Kane on here, potentially a couple other folks. Tony, thanks for tuning in. We had a great time with the folks down at Leica. Again, we can't say thank you enough for all the folks taking time to hang out here with us today. One quick question I'm going to put an end to real quick. Yes, you did notice that is a CX145D with an offset boom behind us. That's something a little different. We're glad to have that here as part of our set this morning. Tim Leaf, just to close the loop on the conversation that's in the chat window there. We talked about it during Brad's video there a little bit. I would definitely talk with your dealer a little bit more about that. At no point do we recommend removing any of the rubber parts from a rubber track or rubber undercarriage. Definitely talk with the local dealer about that. All right, gentlemen, we're going to dive into some of the other questions that have come up. The first is from Roger Armstrong. He says, you mentioned that traveling or operating in reverse causes twice as much wear on the undercarriage as operating forward. At what distance is that not correct? And he throws out the example of a 40-foot cut and fill operation versus an 80-foot cut and fill operation.
I'll take that one. Good question. I guess the first statement is it's always correct that when you're in reverse, you're accelerated wear. So I think it highlights the importance of a job plan and trying to minimize your overall reversing operations as you do your job plan. We know it's not going to be avoided, but when you have that planning in place, you can minimize the total distance you're reversing. So,
yeah, as with many things, these are best practices. We know that every job site is different, every operation is different. These are general best practices. Patrick Hamer here has a question. He says, I have a CX37C rubber track, slope parallel to the contour, driving in softer dirt. I slip tracks. I try to avoid that, but it happens a lot. I have them tensioned to specs, but it seems that a bit tighter would help, although may damage over time. Any suggestions for this gentleman with a mini excavator with a rubber track?
Yeah, Bill, I'll take that one. Really, the core of the recommendation is to have your dealer come out and take a look at your specific application, your specific environment, and proceed from there. I think one of the underlying ideas here, though, is it enforces the importance of regularly checking the tension of those tracks. If you check it more regularly, you can keep a better finger on the pulse, if you will, on if they're getting a little looser, if they need to be a little tighter. If it's a little bit of time in between those checks, there may be some stretching or some hard pack in there that's tightening the tracks that is going to affect how those stay on the rail. But at the end of the day, highly recommend having your dealer come out, take a look at those, and see your exact application.
Thanks, John. A lot of interest here in the topic of undercarriage measurement. John, one of the questions that has come in here, if I want to have my undercarriage measured, who do I reach out to? What is our recommendation to folks there?
Sure. Really, again, best practice is to have your dealer come out and take a look at that. They have the resources available to accurately and efficiently check the wear on that undercarriage. But again, something that you can do in between that is to regularly check visual inspections, looking at the wear of that, just keeping a really good finger on the pulse of what's it looking like.
Thank you, John. Question came in here, and Jeremy, I will throw this one to you. We talked on dozers about the different track widths and whatnot, but question came in here, can I get an extended life track on a case dozer? What do we say to that, Jeremy?
Yes, you can. So our standard configuration, which we call our heavy-duty salt configuration, that's on all the models, is our standard offering. We do offer extended life version. The 650 through 1150, it's our max life, so that's an extra dry rotating bushing on the pin. And then for 1650 through 2050, we have a sealed and lubricated bushing design. So those are our extended life offerings. But I do want to mention it is important to know your most common application, because in certain applications you may not see the extended life. So we actually may recommend the salt. And a couple quick examples would be if you're in a fine abrasive sand, actually the salt will give you may not see the extended life. You're going to get the life, but you may not see the extended life. And also if it's a high impact, we would recommend that you stick with the salt heavy duty. So it's important to know your most common application, and then we want you to give the longest life for your investment.
Thank you, Jeremy. Another question here. Can I get steel tracks on a CTL? John or Jeremy, I'd throw that out to either of you.
Yeah, I'll take that one. So for most case CTLs, you can get steel tracks aftermarket. The standard factory offering, if you will, is rubber tracks. However, the exception to that is on the 620B. Those do have an option for factory steel tracks on that machine.
Thank you, John. Jeremy, I'm going to throw this one to you as the, your day job when you're not hosting Case Live as the dozer product manager. Are you having problems getting undercarriage parts, and are you continuing to have supply chain issues?
Okay, good question. I would say there's no exception with undercarriage parts with some of the supply chain constraints that we are, the whole world is facing. But the best proactive measure is to do what we've been describing, is to have a regular monitoring of your wear. Because if you regularly monitor your wear and you know how you can project when you would want to replace a part, you can put those parts on order with your dealer, and your dealer can, there should be no issue of waiting for parts if you know your wear rates on your undercarriage component. So yes, there's supply chain issues that are similar to other parts, but the best cure for that is scheduling your maintenance and repair of your undercarriage by understanding where your undercarriage is wearing. So,
John, I'm going to throw this to you. Where can I get one of those handy dozer reference charts you showed us?
Absolutely. So, quick answer is they come with every M-Series dozer from the factory currently. Actually, if we go and look in the cab, of the dozer behind us, you can see here that we've got the laminated quick reference card zip tied to the operator station, very close to that operator. So on one side, we've got the wear charts that can show you how to recognize accelerated or uneven wear on all of those undercarriage components. And then on the other side, we've put a quick maintenance chart so you can have a really good idea as to what preventative or scheduled maintenance we need to take action on at any given time for that undercarriage to extend the life of it.
Thank you, John. I'm going to toss this one out to both of you. How often should I check track tension?
I'll take that. Honestly, it could be a multitude of different things, but really the core of it is regularly. So you could do it daily, you could do it weekly. I would say one of the most important times to check is when you're changing material types that you're working in. Anytime you go from a sand to a clay, after operating for a little bit, get out, check that tension, and make sure that it's in spec and we don't have any pack in that track that's causing tension. It's really easy to check the tension of your track. In fact, it's in the operator's manual. On the other side of the dozer, there's actually a chart, and it's really just as simple as if you look at the track, you're literally just measuring the sag of this track from your carrier roller to your front idler, and then your carrier roller back to your sprocket. So it's literally just putting a straight edge on top of the grousers, measuring from that straight edge down to the top of the shoe. And if it's then spec, you're good to go. If it's a little loose or a little tight, we just need to add a little bit of grease. And then you can see on this track specifically, we've got our grease zerk right here. If it needs to have tension added, we simply put some grease in. And if we need to remove tension, we just take a little bit of grease out. And again, the proper procedure for that is in the operator's manual.
Thank you, John. There's another question here that has come in, and I'm in the absence of Nathaniel and because of where I'm standing, I'm actually going to take this one real quick. Talks about, is the rule about digging over the back or the side of the excavator a hard rule? And I think just like everything else we've talked about here in this case live so far, these are best practices, these are tips. We know that every job site and every situation is going to be different. On this excavator, it's easy to tell what is front and back. The dozer blade is the inherent natural front of the excavator. We don't want people digging over the back sprocket. We want people to dig over the front idlers. And again, as Nathaniel mentioned, when you dig off the side, think of that action of digging off the side over here. You're putting that weight and the pressure all on one side of the tracks. Excavator tracks are really built a little bit more for moving from point A to point B instead of tractive effort like a dozer's undercarriage is. So that's a little bit of a different use case there. Again, a best practice. We understand obviously there are situations where you have to dig over the side or you have to spin around and dig over the rear of the excavator. We're sharing tips with you here this week that are going to help you get a little bit more life out of those tracks. John, to that point, question here on track spinning. How do I prevent track spinning?
Great question, Bill. Probably the first and foremost easiest answer to that is going to be raise the blade a little bit, right? Take a little bit less of a cut. But a couple other things that you can do. One of the things that's actually really easy for an operator to do is to look at the blade pitch. They all six-way blades on our dozers have the opportunity for the blade pitch to be adjusted. It's as simple as a turnbuckle on the front of the blade that can lead the blade, top of the blade forward or back. That position of that blade will change the aggressiveness or the ability of that machine to cut. The further the blade, top of the blade is forward, the more aggressively it cuts. And the further back it is, the better it carries or spreads material. So if we go from a light sand material, we may not have to have it as far forward, but if we go from that sand to a heavy clay, we'll need to move that forward a little bit, let that blade cut a little bit easier, have less spinning, better effectiveness of our power.
Awesome. Thanks, John. And this is the time of day where I remind you we've got a few more minutes here to take a few questions. Drop them in that Q&A box. I'm monitoring the chat box as well, but I am a simple man, and the Q&A box is where I'm definitely going to check for things. A question here for added clarification on the operating in reverse thing. What is the big difference in reverse than forward that causes the extra wear?
Sure, I can take that as well. So the difference is when you're going forward, the way that track goes over the rear sprocket, you have better tooth to bushing retention. When we start going in reverse, physics is kind of working against us, and we have less tooth of the sprocket to the bushing retention. So you've actually got, when you're going forward, right, you've got good, probably 60, 70% bushing to sprocket retention, and when you go in reverse, that bushing starts to climb that tooth a little bit towards the 50, 45%. And again, material packed into that track and that undercarriage can even further reduce bushing to tooth retention. So that is really the physics or the nuts and bolts as to why we wear faster in reverse than we do in forward.
Thanks, John. Question coming in from Judson. And Judson, I'm going to preface this by saying we have our dozer experts and our excavator experts here today. Our CTL guy is not here with us today, so if we don't give you the perfect answer here, we're going to follow up with you after the show here today. But Judson asks, how do you know if the tracks on a CTL are not aligned correctly? And I would throw out a general answer that if you have concerns about the alignment of your tracks on your CTL, that is certainly a discussion to have immediately with your local case dealer. But gentlemen, any thoughts on whether a CTL's tracks are properly aligned?
You know, one of the things you could look for, depending on what type of material you're operating in, right, if you're on an improved surface or even if you're in dirt, you might be able to see some odd tracks in the dirt or skid marks maybe, showing that we might be skidding and dragging rather than being aligned and rolling with less effort. That could be something to look for.
Yeah, and as always, again, if you have concerns, check with your local case dealer. They will be glad to have that discussion with you. A trick question here. I'm just going to use the first name, Peter. Good morning, Peter. How you doing, sir? Trick question here. I think we all know the answer, but it's worth reiterating. How often should undercarriage tracks be cleaned? What is our mantra that we share with people there on cleaning undercarriage tracks?
I can take that. As often as possible, honestly. Definitely daily, but on your brakes, if you see it packing up in your undercarriage, take that moment to clean it out. And honestly, it's easier to do it the more often you do it. So I've cleaned some tracks, and if you let it go all day, it's going to get more packed, and it's actually harder. So if you do it as often as you can, when it starts to build up, that's the easiest, and that's definitely the recommendation.
Yep, and I would even expand on that and to say, near and dear to our hearts, being here in Wisconsin, wintertime, very important, right? Because if we get that hard pack in, if there's any bit of moisture in there, we've got that potential for freezing. And if that hard pack or the material packed into the tracks freezes, that gives us even more opportunities for component damage, misalignment, accelerated wear. So extra attention in the wintertime is ideal. But as Jeremy said, as often as possible, at minimum daily.
Question has come in here, and it's, I get it because it's not necessarily a natural connection. Richie touched on it. Richie, very excited, was glad to have him back in Case Live today. But question here about how does machine control affect undercarriage life? I get the question. Maybe can we expand on that a little bit as to how machine control can help that extend its life?
Absolutely. I'm not going to be quite as bubbly as Richie was on this explanation, but I'll do my best. So with machine control, that really, it doesn't have any actual connection to the undercarriage or the tracks itself. The idea is behind the improved overall operation. So with machine control, especially when you go to 3D machine control, you can really visualize the job site very clearly, very well. You can look at the plan, you can get a really good idea as to where material is going to be cut, where it's going to be filled, and you can, as we said earlier, make a plan for that job. Think it out ahead of time, work more intelligently, work smarter, not harder necessarily. But when we're doing that and letting the machine control help us visualize and make the right cut, not overcutting, or even with excavators, not over-excavating, moving that material once, we're having less passes to that finish or target grade. And anytime we can have less passes, we get the job done quicker. There's still the same amount of work to be done. That's the common bottom line. but we can get that job done quicker, and we can put less passes on the machine, less maintenance, less fuel burned. There really are just a ton of benefits to using machine control.
And Richie, as you're describing it there, Richie just chimed in the chat box, and he says, "I'm just excited about the technology." We know you are, Richie. That's why we love you. Last question here I'm going to throw out. Again, if we didn't get to any of your questions, we'll follow up with those after the show here. What components are measured in an undercarriage measurement?
Yeah. Again, no problem taking this one, and Jeremy, feel free to chip in. Really, short answer is any moving component on that undercarriage. You know, you've got your chain links, you've got your outer bushing wear, internal pin and bushing wear, sometimes called pitch or pitch extension, your front idler, your carrier rollers, and your track rollers. Those can all be physically measured with calipers and rulers and such. Your sprocket, however, that can't be physically measured. There's no defined point to measure to or from. But again, we highly recommend that you're at least looking at that visually every day to try to catch some of those odd or accelerated wear early to replace.
And as always happens, and we love the questions. When I say last question, there's usually one that flies in here right under the bell. Al jumps in with, is there an average life expectancy for rubber tracks? And I think I'll just quickly reiterate that's what we've been talking about, is that every application is different. If you have a rubber track machine and hard-packed gravel, asphalt, concrete, rock, that track is going to deteriorate. That rubber track is going to deteriorate quicker. If it's in softer material, it's going to work much longer and have less of that abrasion and resistance to it. So that's always a conversation to have when you are in the consideration purchasing process with your local case dealer on where that machine is working and how that track option is going to perform based on the work you do. With that, thank you all for joining us here today. I'll remind you here just for a few more moments while the feed is still live. I did drop, and I'll drop it in here again. Very excited. Undercarriage, this is one we were very excited to do, but very excited as well for the next case live, which is going to be on outfitting your backhoe, all the cool features and options and things you should consider. John, Jeremy, any final thoughts from either of you guys?
Nothing.
Again, just really want to stress, always be looking at that undercarriage, doing that daily inspection, catching those problems when they're small and easy to fix, as opposed to waiting for them to snowball into a potentially larger, more expensive repair, and then just, yeah.
Thank you guys so much. Thank you all at home for joining us here on Case Live, and we will see you the next time. Have a good day, guys.